I'm going to walk you through the steps to analyze data from these Galaxy proteomics experiments in R. So, a Galaxy is great. It has a lot of tools. It actually has some built-in visualization tools. But if you are a graduate student or you are working for a company in a bioinformatics internship, you're not going to want your final plot to be the Galaxy plot. The Galaxy plot's really useful for sort of seeing what it looks like, but to get a publication quality plot, we want to go to R. There's just a lot more tools. Once we unlock that ggplot2 suite of tools, we can do a lot of formatting changes. We have those nearly infinite colors with the R colors tool. So we really are going to have a lot more choices and be able to make it look a lot better. So we need to get the file, and you can get it in a couple different ways. You might already have it on your computer because you recently completed 313. You can go to 313 and just look at your submission, or you can go to Galaxy, scroll through the MSStats tutorial where you did a label-free max quant analysis plus MSStats, and look for the step in your history that you renamed significant proteins. Save this file to your computer and then upload it to Posit Cloud. So you can see my file is right here, Galaxy 24 significant proteins, and you can read it in. I'm going to clear my console and my environment to have a clean start, and then let's walk through the steps for this assignment. When we read in the file, you want to set the separator to be a tab, since it's a tab delimited file. And we want to check that if I have separator tab and header true, it reads incorrectly. So I'm going to double click on it. First thing I want to see is that the column names are actually column names and not data. So that looks good. And then I want to look at the length. It's 148 observations. If I go back to Galaxy, I see it's 149 lines. So with a header, I'm getting the same length on both Galaxy and Posit. So I feel good about that. I feel like it read in well. And now I can walk through all the steps in the assignment to clean up the data so that I'll be able to use it to make a plot, a publication quality plot. So I want to simplify to only 3 columns: protein, log2 fold change, and p-value. The easiest way to do that is with the column numbers. So I'm going to look at the data and see what column each of these columns that I want to keep are. So protein is column 1, log2 fold change is column 3, and p-value is column 7. So I can keep those columns by making a new variable called myCol. 1, 3, and 7, those are the columns I want to keep. And then using square brackets to put nothing on the row side, I want to keep all the rows, and myCol on the column side because I only want to keep those 3 columns. Once I run that line, I end up with a new data frame, same number of rows, but now only 3 columns. And I look at it, it is the 3 that I want: protein, log2 fold change, and p-value. Now I need to clean up the rows. All of the data is not going to be plottable. So whenever we do a calculation of the significance and abundance between 2 proteins, I'm going to end up with a couple of rows where I get infinities for log2 fold change, and for the p-value, I get an NA value. So those rows are not going to be something I can fit on the plot. I can't plot positive infinity, or there's probably even a couple negative infinities in this file. So I need to make sure that I get rid of those rows. There's a lot of different ways to do that. One fast way is with complete cases. So complete cases will be true or false based on the whole spreadsheet. Anything that has an NA will be false. Anything that doesn't have an NA will be true. So if I put complete cases command on the row side, it will only keep the rows that don't have NAs. So I run this, I keep all my columns, but I only keep 99 rows. And I can just scroll through the data and see that indeed all the log2 fold change and p-values are now numerical. Now I need to do something that we have not done the whole semester. So the whole semester I've been trying to teach you guys to get rid of row names, not keep them. They work really well in R. We use them a lot for plotting, but they're not super helpful in Excel. So if you're exporting the data for a user to open in Excel, doesn't really make sense to keep the row name there. It looks like a column without a title. For our next plot, we need row names to be defined so that we can use those as a label on the plot. So I'm going to change the row names of my SIG3 to be the protein column. If I click on this, you can see what it looks like. So now all the row names, instead of being numbers, are protein identifiers. And now I have that data in two places. I want to delete that first column. I don't need to put the information in two spots. And now I have everything I need for using the volcano plot tool in the next assignment. In order to save this, I'm going to use write.csv to write to the computer, and just make sure that you change the name of the file to be your last name significant, and set row names equal to true, but quote equal to false.